Hi, welcome to this tutorial on ANSYS Workbench Mechanical. In this tutorial, we are going to review the fatigue analysis of Formula SAE suspension control arm. The design goal of any suspension component should be balanced between flexibility, strength, and safety factor under cycling load. Here you can see the whole suspension system with all active force on one wheel, including bump force, braking force, and cornering force, which comes from the centrifugal action of the whole car. To find the active force on each member, first you need to use the ANSYS rigid body dynamic tool or just a simple freeway diagram to calculate the reaction force for each joint. Then you can use those reaction forces and calculate the resultant force for each member. Here, for the lower arm, the resultant force will be 9,000 Newton along the length of each arm. The material for this analysis is going to be structural steel with 250 megapascal yield strength. Let's move on to the FEA model. Here I have a blank workbench project open. First, you need to select the correct unit system, which in this case is going to be metric. Next step is adding the analysis system to my project. For this simulation, we need a static structural. You can double click or drag and drop a static structural to your project. The first cell is engineering data, which shows your material property. The default material for ANSYS mechanical is structural steel. You can review the Young modulus, Poisson ratio, yield property, and change them if you need to. For this analysis, we're going to use the default material property. You can close the engineering data tab and go to the next step. Right click on the geometry cell and locate your geometry file on your hard drive. So far, we have defined the material property and we imported geometry. Now we can open the ANSYS Workbench Mechanical. This is ANSYS Workbench Mechanical environment. First, click on the geometry and make sure the material assigned to your geometry is structural steel. Next step is meshing the geometry. The ANSYS static structural default mesh is TED, which is working fine for this analysis. But we are going to add some mesh control to constrain the size of the element. Click on the mesh control and select sizing. For the geometry selection, change your entity to body and select the whole lower arm and apply. Now we need to define the maximum element size. Click on the element size and use 5 mm as the maximum element size. Right click and generate mesh. Next step is applying boundary condition. Click on the static structural, choose the face entity, select the ball joint end, and add a fixed support here. Select the faces of the mounting arm and insert the force here. The magnitude will be 9,000 Newton and the direction will be along the axial of the arm. The same with the other mounting joint. Next step is adding the results we need from this analysis and run them out. Click the solution. We need total deformation. We need 1 Mises stress. We need the stress tool. Click the solution again. And we need fatigue tool. For fatigue, you need to define what kind of loading we have. By default, it shows fully reversed, but in this case, because of those braking force, bump force, and cornering force are changing between 0 and max, we use a 0 based. And for fatigue tool, we select life. Let's run the model and review the result. First result, total deformation. The maximum total deformation is 0.2 mm, which is acceptable compared to the size of the arm. Maximum 1 Mises stress is 172, where it happens near the ball leg joint. The stress tool and safety factor shows the average safety factor is about 5, but the minimum safety factor is 1.445, and it happens near the ball joint end where we had the maximum 1 MISA stress. Let's take a look at the fatigue life. The fatigue result shows almost everywhere we have infinite fatigue cycle except near the ball joint end where the fatigue life is about 9.82 e to the 5 fatigue cycle, which means if we want to have the infinite fatigue life for the whole arm, we just need to get rid of stress concentration at this end. This concludes our tutorial. Thanks for watching.